We will conclude our study of logic by looking at quantified arguments, that is, arguments in which the statements have quantifiers. So universal instantiation. If a property is true for everything in a set, then it is true for any particular thing in the set. The most common example of this is an extension of the Socrates example from before. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Universal instantiation is the fundamental tool for deductive reasoning. We will now look at the extension of the two most common syllogisms. We have universal modus ponens. For all x, if p of x, then q of x. P of a for a particular a, therefore q of a. So we're going to rewrite this argument formally and then determine whether it is valid. So first, formal. So we're going to let e of x represent x is an even integer. And we'll let se of x represent that x squared is an even integer. So to write this formally, we would have for all x, e of x implies se of x. E of k. Therefore, se of k well, isn't this an example of universal modus ponens? So this would be a valid argument. Write the conclusion that can be concluded. So if T is any right triangle with hypotenuse C and legs A and B, then C squared is equal to A squared plus B squared. Little t is a triangle with both legs equal to 1 and a hypotenuse C. Therefore, what? Well, therefore, C would have to equal root 2, and here's why. Since we know that little t is this should be right triangle. Since we know that little t is a right triangle with both legs equal to 1 and a hypotenuse of C, we know that C squared would have to be 1 squared plus 1 squared, which is of course 2. And then from there, we reach our conclusion. Universal modus tollens. For all x, if p of x, then q of x. Not q of a for a particular a. Therefore, not p of a. Again, we're going to rewrite the following argument formally and then determine whether it is valid. All human beings are mortal. Zeus is not mortal, therefore Zeus is not human. So we'll let h of x equal x is human, and m of x to represent x is mortal. So this argument would be for all x, h of x implies m of x. Then we have not m of Zeus, therefore not h of Zeus. Well, if we look at this, isn't this universal modus tollens? And so this would be valid. So we're going to write the conclusion that can be inferred. All professors are absent-minded. Tom Hutchins is not absent-minded. Therefore what? Well, all professors are absent-minded. Tom Hutchins is not absent-minded. So by universal modus tollens, we can conclude that Tom Hutchins is not a professor. So next we look at a couple fallacies. So we have universal converse error. For all x, if p of x, then q of x. Q of a for a particular a, therefore p of a. Then we also have the universal inverse error. For all x, if p of x, then q of x. Not p of a for a particular a, therefore not q of a. And notice that the universal converse error and the universal inverse error are natural extensions of the converse and inverse error we studied before when we looked at arguments. Just as universal modus ponens and universal modus tollens were natural extensions of modus ponens and modus tollens when we studied arguments. Now, with quantified arguments, there is another way to determine whether the argument is valid or not, and that is to use Venn diagrams. So we'll use a diagram to show the validity of the following argument, which was all human beings are mortal, Zeus is not mortal, therefore Zeus is not a human being. We've already determined that this was a valid argument because it's universal modus tollens. So let's now look at drawing a Venn diagram to verify it. So let's say this disk represents all mortals. And let's say that this disk represents all humans, right? Now, humans has to be immortals, right? Because it says all human beings are mortals. Now, then we have that Zeus is not mortal. So Zeus cannot be in this circle of mortals. So let's stick him out here. Right, so there's Zeus. Well, since Zeus has to fall outside of mortals, there's no possible way he can fall within the humans. And so this is valid. So let's look at another example. Let's determine whether this argument is valid. All human beings are mortal, Felix is mortal, therefore Felix is human. So we're going to have the same circles as the previous example. So let's say these are mortals. These are humans. So now we need to place Felix somewhere. Well, Felix is mortal, so we could put Felix here. Well, in which case he'd fall in the realm of humans. We could also put Felix here, which does not put him in the realm of humans, but he's still in the realm of mortals. So this argument is invalid. Let's determine the validity of this argument. No polynomial functions have horizontal asymptotes. F of x has a horizontal asymptote. Therefore, f of x is not a polynomial function. Okay, so no polynomial functions have horizontal asymptotes. So we need two circles. Let's say this is polynomial functions. Over here, we have has a horizontal asymptote. Right now, we can't have horizontal asymptotes in polynomials. That's why they're separate circles. Now we're told that f of x has a horizontal asymptote, so it has to fall over here. Therefore, f of x is not a polynomial function. Well, that's valid. It's true, right? Because it's falling in the circle of horizontal asymptotes, there's no possible way for it to fall in the circle of polynomials. So this would be a valid argument. And now let's look at one final example using a Tarski's world. We wish to reorder the premises to make the argument valid. So we have three premises. The first premise is that all the triangles are blue. The second is that if an object is to the right of all the squares, then it is above all the circles. Finally, if an object is not to the right of all the squares, then it is not blue. Our conclusion is that all the triangles are above all the circles. All right, so let's take a look. If we start with the premise all the triangles are blue, and we put that together with the second premise, can we conclude anything? So we have all the triangles are blue. If an object is to the right of all the squares, then it is above all the circles. Well, that doesn't tell us anything. Let's look at 1 and 3 now. All the triangles are blue. If an object is not to the right of all the squares, then it is not blue. Oh, well, then from universal modus tollens, we have that all the triangles, I'm sorry, this is not universal modus tollens, this is elimination. If an object is not to the right of all squares, then it is not blue. All the triangles are blue. Therefore, all the triangles are not to the right of all the squares. So it looked like that actually 3 should go first, then 1. Well, now we know that all the squares are not to the right, all the triangles are not to the right of all the squares. Well, now if we look at 2, if an object is to the right of all the squares, then it is above all the circles. But we just said that all the triangles are not to the right of all the squares. So it cannot be above all the circles. Oh, I'm sorry. premise 3 and 1 together say all the triangles are to the right of all the squares. Then we conclude that all of the triangles are above all the circles, which is what we wanted. And so the proper ordering should be premise 3 first, premise 1 second, and then premise 2 third. So that concludes our study of arguments with quantified statements, which also brings our study of logic to an end. The next topic we will be looking at is number theory. And in looking at number theory, we will begin to develop techniques of proofs. Proving things uses logic. So if you're rusty on logic, before you view the next video, go back and review all the videos on logic.